Nobody tells you how lonely the universe really is. Stars look close in the night sky, but between them, there's a horrifying amount rid of nothing. I'm going to tell you something that will fundamentally break how you see reality. And I'm not exaggerating. By the end of this video, you're going to look at your hand, your solid physical hand, and realize it's not solid at all. You're going to realize that everything you've ever touched, every surface you've ever stood on, every object you've ever held is almost entirely empty space. And when I show you how much empty space, when I actually visualize it for you, you're going to feel something close to vertigo. Because nothing is what you think it is. Let's go. You think matter is solid. You've been told this your entire life. Tables are solid. Walls are solid. You are solid. You can touch things. You can feel them. They push back when you push them. That's what solid means, right? Wrong. Matter is not solid. Matter is almost entirely empty space. And I can prove it to you. But to understand just how much nothing we're talking about, we need to zoom in, all the way down, to the smallest building blocks of reality. Let's start with an atom. Everything around you, every object, every material, every living thing is made of atoms. Your body contains roughly 7 octillion C atoms. That's 7 sextillion 000 atoms. Now, what does an atom actually look like? Not the cartoon version you learned in school with electrons orbiting a nucleus like little planets around a sun. That's oversimplified. Atoms don't really look like miniature solar systems. But for visualization, let's use a simpler model. An atom has 2 major parts: the nucleus, a tiny dense core made of protons and neutrons, the electron cloud, a fuzzy quantum region where electrons are likely to exist. The nucleus contains almost all the mass. The electron cloud contains almost all the volume. And here's where it gets disturbing. The nucleus is unbelievably small compared to the size of the atom itself. Let me show you. Let's scale a hydrogen atom up to something your brain can actually picture. Imagine the nucleus is the size of a marble, about 1 centimeter wide. Now, where would the electron cloud be? The edge of the atom would be roughly 1 kilometer away. 1 kilometer. A marble in the center, and the edge of the atom stretching a full kilometer in every direction. Everything in between, empty space, not air, not fog, not invisible matter, just emptiness. An atom is basically a tiny speck in the middle of a gigantic void, a cathedral of nothingness surrounding a grain of matter. Let's try another scale, because I need you to feel this. Imagine the nucleus is the size of a pea sitting on the 50-yard line of a football field. Where would the electron cloud be? Not at the edge of the field, not outside the stadium. The atom would extend roughly 2.5 kilometers in every direction, a pea in the middle, and the atom stretching across an entire city. That's how much empty space is inside a single atom. And your body, is made from trillions upon trillions upon trillions of these things. Let's do the math. An average human body weighs about 70 kilograms. That mass comes from atoms, roughly 7 octillion of them. But here's the thing. If you removed all the empty space from those atoms, if you compressed all the atomic nuclei together with no gaps, how big would you be? Tiny. Absurdly tiny. A human body compressed to nuclear density would be only about the size of a dust particle, roughly 0.1 millimeters across, about the width of a human hair. Everything that makes you, your bones, your organs, your memories stored in your brain, compressed into something barely visible. And yet right now, you feel solid. You feel real. Now let's scale this up. What if we removed all the empty space from everything? Not just you, the entire Earth. The Earth has a mass of about 5.97 times 10 to the 24 kilograms. If you compressed Earth down to neutron star density, removing almost all atomic empty space, it would shrink into a sphere only about 220 meters across. Smaller than many sports stadiums, every mountain, every ocean, every city, every animal, every human who has ever lived, compressed into something you could walk around in a couple of minutes. And it would still weigh exactly the same, 5.97 times 10 to the 24 kilograms. That's not a planet anymore. That's a gravitational nightmare. Let's keep going. The Sun. Mass 2 times 10 to the 30 kilograms. If you compress the Sun down to neutron star density, it would become a sphere roughly 20 kilometers across, about the size of Manhattan. You could drive across it in under 30 minutes, and yet it would still contain the mass of the entire Sun. The gravity would be so extreme that standing on its surface would be impossible. You wouldn't just get crushed, you'd get flattened thinner than a cell almost instantly. Because when you compress matter this much, you don't get a star anymore. You get something far stranger, a neutron star. Here's the terrifying part. We don't have to imagine what matter looks like with almost no empty space. The universe already makes these objects naturally. When a massive star dies, gravity crushes its atoms so violently that electrons and protons merge into neutrons. The empty space collapses. What's left is nuclear matter packed together almost as tightly as physics allows. That's a neutron star, and neutron stars are real. Astronomers have discovered thousands of them. A typical neutron star is only about 20 kilometers across, but it contains more mass than the Sun. The density is so extreme that a teaspoon of neutron star material would weigh about 1 billion tons on Earth, about the weight of a mountain compressed into a spoon. And if you dropped a marshmallow onto a neutron star from 1 meter above the surface, it would hit with the energy of a large explosive bomb from a marshmallow. That's what matter looks like when the empty space disappears. Okay, let's address the obvious question. If atoms are mostly empty space, why do things feel solid? Why doesn't your hand pass through a table? The answer is electromagnetic force. When you touch something, the atoms in your skin don't actually physically collide with the atoms in the object. Instead, the electron clouds repel each other. Electrons are negatively charged. Negative charges repel other negative charges. So when your hand gets close to the table, the electron clouds push back violently. That repulsion is what you experience as touch. You're not really touching the table the way you imagine. You're feeling force fields interacting. Every surface you've ever touched, every hand you've ever held, every wall you've leaned against. You are always separated by tiny gaps between electron clouds, floating just slightly above the surface, never fully making contact. The visualization. Now picture it again. If an atom were the size of a massive stadium, the nucleus would be a tiny pea at the center, the electrons would be tiny invisible specks near the outer walls, and almost everything in between would be empty. Now remember, your body contains 7 octillion atoms, all of them mostly empty, which means you are mostly empty. You are not a solid block of matter. You are a cloud of particles held together by invisible forces. And so is everything else. The chair you're sitting on, the floor beneath your feet, the planet beneath the floor, all of it. Almost entirely nothing. The universe. Now let's zoom out one final time. What about the universe itself? How empty is it? The observable universe contains roughly 10 raised to power 80 atoms. That sounds enormous. But the observable universe is about 93 billion light years wide. That's roughly 8.8 into 10 raised to power 26 meters across. And most of that volume is almost completely empty. The average density of normal matter in the universe is incredibly tiny. Only a few atoms per cubic meter when averaged across cosmic scales. Most of space is vacuum. Vast intergalactic voids where galaxies are separated by millions of light years of near total emptiness. And even the tiny fraction of the universe that contains matter, stars, planets, galaxies, is itself mostly empty space internally. The universe is emptiness layered inside emptiness, the meaning. So here's what we know. You are not solid. The Earth is not solid. The universe is not solid. Everything is mostly empty space, held together by invisible forces, creating the illusion of solidity. But here's the beautiful part. That emptiness is what makes everything possible. If atoms were packed completely solid with no space between particles, chemistry couldn't happen. Molecules couldn't form. Life couldn't exist. You need the emptiness, you need the gaps, because inside that emptiness, forces interact, atoms bond, complexity emerges. The void isn't absence, it's possibility. It's the canvas reality is painted on. Look at your hand. Next time you look at your hand, remember, it's not solid. It's a storm of particles, a cloud of probabilities, more than 99.99999999996% empty space. And yet, it's the most real thing you've ever known, because you are not made from solidity. You are made from interactions, fields, forces, particles dancing in mostly empty space. And somehow, against impossible odds, that emptiness learned to think, to feel, to wonder. That's not insignificant. That's everything. If this changed how you see reality, send it to someone before tomorrow's upload. And if you want another existential nightmare tomorrow, subscribe now, because we're just getting started.